Welcome to our AI for Everyone instructional video series. This instructional video series is developed by the American Institute for Professional Training and Development, a nonprofit organization. This educational video series is designed to help everyone learn about AI and explore how to benefit from this remarkable technology. The entire series is available to everyone at no charge. My name is Sandy, and I will be the AI avatar guiding you throughout this presentation. Artificial intelligence is often used as if it describes one thing. It doesn't. There are at least three very different kinds of AI, and most people who talk about AI are conflating two or three of them all at once. In this video, we'll discuss the different types of AI, those that exist today and what might eventually exist. Gaining an understanding of the various categories of AI will probably influence how you think about AI and how you might reflect on things you read about AI. In order to better understand the various types of AI, we need to think of AI as a spectrum with three key consecutive zones. At one end of the spectrum, we start with narrow AI, the type of AI currently available to most people. Every AI system that exists today, every chatbot, every image generator, every self-driving car, every spam filter is run by narrow AI. Narrow AI is basically trained to do one kind of a task. The next item on the spectrum is general AI, or artificial general intelligence. There is some debate about its definition and about exactly where we are with AGI. Generally speaking, AGI is what you imagine when you picture science fiction robots. Robots operated by AI systems that can do anything a human can do. There are some who argue that we are at the early stages of AGI, while others contend it does not exist yet, and that we are not even close to having AGI. This takes us to third item on the spectrum, artificial superintelligence, or ASI, an AI system that exceeds humans at every intellectual task. This is still a theoretical AI capability. However, some researchers think about it seriously. It still does not exist, and there is no clear timeline as to when, or even if, it will become a reality. Most AI talk is centered around the first zone, or narrow AI, while most AI anxiety is about the other two. Let's begin by focusing our attention on narrow AI. Narrow AI focuses on one specific task, and only that task. A language model that is trained to write and chat cannot play chess. A vision model that is trained to detect tumors and X-rays cannot hold a conversation. A game-playing AI that beat the World Go champion has absolutely no idea what Go is. It just found moves that maximized a reward signal. The AI that operates an autonomous, self-driving car is trained specifically for that function. It is not designed for doing anything else. This sounds like a limitation, and it is, but it's also what makes these systems so powerful within their specific domains. The narrow focus means a deep specialization in a single domain. A narrow AI is just like a master craftsman who excels at making precision clocks with extraordinary skill. If you ask them to bake a loaf of artisan bread, they will probably be lost. Most people have had some experience with narrow AI. When you search for something online, a narrow AI ranks the results. When your phone guesses the next word you're typing, that's autocomplete, a narrow form of AI trained on billions of text messages. Your email spam filter is a classifier that also decides which category each incoming message belongs to uses AI. Streaming recommendations are generated by a narrow AI that studied your viewing history. A medical imaging AI that flags anomalies, which are easy to miss at high volume, is a type of narrow AI. The bank's fraud detection system, designed to spot unusual transaction patterns in real time, is using a narrow AI. None of these systems know about each other. None could do each other's jobs. They're all specialists. Now let's talk about artificial general intelligence, which is fundamentally different from narrow AI. Artificial general intelligence, or AGI, is a system that can do anything a human can do. In other words, it has the ability to transfer learning, which means that it can learn a skill in one domain and then be able to apply that same knowledge in a completely different one. The same way that a person who's good at chess also tends to be good at other strategy games, good at strategic planning, and also good at recognizing patterns in other fields. Artificial general intelligence would also have developed common sense. It would be able to understand the physical world without needing every fact explicitly programmed in. It would know that if you knock a glass off a table, it will fall, without being shown 10,000 falling glass videos first. AGI would also have the ability to set and pursue its own self-directed goals. Not just respond to prompts, but direct its own learning and effort toward objectives it identifies as worthwhile. None of today's AI systems do any of these things reliably. LLMs may approximate some of it, some of the time, which is why sometimes they get called general AI, and why that label continues to be debated and disputed. There are three fundamental problems that would need to be solved for artificial general intelligence to exist. None of them have been completely solved yet. The first unsolved issue is common sense reasoning. AI has no intuition about how the physical world works. Unlike a child who knows that spilled milk runs downhill and that you can't fit a large box through a small door, AI doesn't know any of these things unless explicitly trained on them. A child knows, but an LLM guesses. The next challenge that has not been overcome is the ability to transfer learning. Current AI learns one domain at a time. Humans are able to transfer and apply knowledge from cooking to chemistry, from chess to negotiation, from language to music. AI can't do this. Training AI on a new domain doesn't benefit from what it learned in other domains. Humans can do this constantly. AI still cannot. Another issue that has not been solved for AI: grounded understanding. AI has never actually touched anything, seen anything, or experienced anything. All of its knowledge comes from patterns in text and data. It reads about pain, but it has never experienced hurt. It reads about friendship, but it has never had a friend. Whether understanding is even possible without that grounding is still an open question. But the absence of this grounded understanding is critical and does matter. Naturally, some people are curious about how close we are to AGI. The honest answer is nobody really knows. In 2012, deep learning produced AI systems that surpassed humans at specific narrow tasks for the first time. That was a genuine breakthrough. In 2023, large language models like GPT-4 and Claude surprised even their creators with the breadth of tasks they could handle. Some researchers called this sparks of AGI. Others strongly disagreed. Looking ahead to the 2030s, the estimates range from AGI within 5 years to we'll never get there. Researchers at the world's top AI laboratories disagree about the timeline. That's not feigned humility. It reflects genuine scientific uncertainty about whether the remaining problems can be solved at all, let alone soon. If AGI is still speculative, why talk about superintelligence at all? ASI? Or artificial superintelligence, by definition, would exceed human capabilities not just in one area, but across everything: scientific discovery, strategic planning, creative work, and ethical reasoning. All of it, simultaneously. There are 3 reasons serious researchers discuss this now, even though it's still theoretical. First, it's important to mention that AI capability has been growing faster than most prediction models anticipated. Second, if AGI does become possible, the transition to something more capable might happen very quickly, potentially much faster than humans can monitor and respond to. Third, the decisions made as we approach and cross an AGI threshold could be extremely hard to reverse. The point isn't to predict when or whether this happens. The point is that getting the foundations right now, the values, the oversight, the governance, matters enormously, before we're in a position where we're scrambling or reacting to something unexpected. AI safety isn't just a concern for a hypothetical future. It's a present-day problem. We need to be careful about alignment. An AI optimizing for the wrong objective can cause real harm, even with no malicious intent. An early content recommendation algorithm was optimized for engagement and inadvertently amplified outrage and disinformation. Because outrage is engaging, the system was doing exactly what it was trained to do. That's an example alignment failure. The possibility of misuse is another major issue of concern. The same capabilities that make AI useful for writing and coding also make it useful for generating disinformation, creating convincing deepfakes, or drafting persuasive extremist content at scale. This is a harmful misuse of AI. Another matter of great concern is the concentration of power. Only a small number of companies and governments currently have the compute power, the training data, and the talent to build frontier AI. That concentration of capability creates real questions about accountability, access, and who gets to decide how powerful AI systems behave. These aren't distant concerns. They're very real, serious, and pressing issues for us now. Let's ground our discussions with some calibrated expectations, things we can say with reasonable confidence versus things that are genuinely uncertain. In the near future, within the next few years, we expect more capable, narrow AI. LLMs that are rapidly improving at coding, reasoning, and working across modalities. Narrow AI is automating more and more tasks that previously required human expertise. These are trends already in motion. In the next decade, it's plausible that we'll see systems approaching human-level performance across a wide range of domains. Whether that counts as AGI depends on your definition, and as we mentioned earlier, researchers are divided about that. What's clear is that the line will keep blurring. Beyond that, it's genuinely unknown. Timelines are contested. Predictions abound, and a breakthrough or an unforeseen event could change the picture entirely in either direction. No credible researcher has a crystal ball that can give us clear and confident outcomes for the future. A healthy skepticism is appropriate when it comes to the future of AI, and asking serious questions about the development process is also crucial. Now let's review our 3 takeaways. Number 1. The AI we currently frequently use is narrow AI. Every system, from ChatGPT to self-driving cars to spam filters, is trained for specific tasks. Number 2. AGI is genuinely hard, and timelines are genuinely uncertain. Common sense, transfer learning, and grounded understanding remain unsolved. Expert estimates differ by decades. Number 3. AI safety matters before superintelligence arrives. Alignment, misuse, and power concentration are all present-day challenges, not distant hypotheticals. Thank you for watching. I look forward to having you join us in our next presentation, where we will explore how AI learns, training methods, data used, and feedback. We will take a full journey from raw data to a working model, exploring how human feedback shapes AI behavior at every step.